Welcome everyone to the digital communication session. Now in this lecture 8 digital modulation schemes, we will start the digital modulation schemes. Now this will comes under unit 3. Now before starting this digital modulation scheme, I just want to give you the brief of about this unit 3. Now in unit 3 we have to do the digital modulation. Now before starting this digital modulation schemes, that comes under in band pass modulation schemes. Now so far we have done how we are generating this analog signal, how we are generating digital signal from analog signal. Now we are converting analog to digital by PCM, delta modulation, ADM, adaptive delta modulation, pulse code modulation. These are the scheme that is used to convert our analog to digital signal. Now this PCM pulse code modulation is not the modulation, we are doing the modulation here. It is the encoding schemes. These are the encoding scheme. These are not the modulation. Just clear in that. Is not the modulation schemes. Modulation scheme that we will do, that is ASK, FSK, PSK. This all comes under the modulation scheme. This is not the modulation scheme. Pulse code modulation, delta modulation, adaptive delta modulation. Although we are converting analog signal into digital signal, we are getting this 1010 signal, but this is transmitted directly through transmitter. There is no carrier involvement. No carrier. This is the band limited modulation technique. Band limited techniques. Now these are the band pass modulation technique. Here we are shifting the frequency spectrum of the digital signal and we are superimposing on it on the carrier signal. Now see here, band pass modulation and demodulation. This is the message source, that is our digital signal transmission encoder modulator. Here in this modulator you can see we are mixing it with the carrier wave. We are converting similarly digital signal into analog signal, and this, because this carrier is in analog nature, this carrier will carry our message through channel and detector will receive that analog signal, and in receiver end it will convert it back to into digital signal, that is 10101 form. Band pass modulation is the process by which some characteristic of sinusoidal waveform is varied with respect to the message signal. The modulation, that is shift the spectrum of the baseband signal to some high frequency. Now what will the modulation do? That will shift over baseband signal spectrum to high frequency spectrum. Now why do we need digital to analog conversion? Why we are converting this digital signal into analog signal and then we are transmitting? Because the medium channel is band pass and multiple users need to share the medium. This analog signal can be transferred up to long distances. Whereas if we transmit this signal, this is the band limited signal that will be used for the short communication, short distance communication. Now here you can see there are the different type of channels is there we can use to carry our data. Now what is modulation? We have also done in the modulation the process of converting digital data or a low pass analog to band pass analog signal. Basically we are converting our digital data. This digital data is converting into analog signal because we are placing this digital signal over carrier signal. Now carrier signal can be varied with respect to frequency, with respect to amplitude, with respect to phase. We can vary the properties of the carrier signal. Modulative signal, high frequency signal that takes the basics of the information signal. Carrier signal, now what is carrier signal? That will carry over information, it will carry over data, and if we mix the modulating signal with this carrier signal, then it's become modulated signal. Now here you can see this is the modulating signal which in having low frequency is the spectrum for this digital signal, and this is the high frequency band pass range for FP, and we are mixing those two signal that will give you the band pass channel. Suppose this is FC and this point is FC plus FB and this is FC minus FB. So here we are using the band pass channel. We are placing the modulating signal over carrier signal. So what is the necessary for this doing this modulation? As we have done in analog communication, why we need modulation? Because we can reduce the practical size of the antenna. As we are increasing the frequency, the size of the antenna will be decreases. It is evident that the efficient antenna of the realistic physical size is needed for the radio communication. Now, as we increase the frequency, the interference is also reduced in mixing the modulating signal. Now, modulation is also required if channel has to be shared by several transmitters. For FDM, TDM, modulation is required. Now, what are the different type of digital modulation schemes? Now, in digital, we understand this word digital, that is over 1010 signal. Modulation, we have understood this term, that is we will mix this digital signal with the carrier signal. Now, there is a different type of method we can mix this signal with the carrier. First is amplitude. Now, the carrier signal this is carrier signal A cos 2 pi FCT plus theta. Now, the properties of the carrier can be varied with respect to this digital signal, modulating signal. Now you can see the properties of carrier signal. This A is the property, another property is the frequency, and another property is the phase of carrier. Now, this phase, amplitude, phase, frequency, amplitude can be varied with respect to this digital signal. So, if we vary the amplitude of the carrier, then it is known as amplitude shift key ASK. If the frequency vary, phase shift key. If the phase vary, PSK. If the amplitude and phase vary, it is APK. Right? For binary signal, binary means we are sending 0 or 1 only. Data comprises of only 0 and 1. Then M equal to 2. This is the 2 combination, that is known as BASK, BPSK, BFSK. Binary amplitude shift key, binary phase shift key, binary frequency shift key. If M is greater than 2, if M is binary digit is greater than 2, then it is classified as a M array modulation detection technique. Right? Now, first modulation technique is ASK. Now, what is ASK? Amplitude shift key. The amplitude of the carrier is switched between the two levels according to the digital data. Now, here we are varying the amplitude of the carrier signal with respect to modulating signal. Here we are mixing this digital data, carrier signal, or over ASK waveform is generated. BSK is also known as on and off keying. 1 and 0 represented by the amplitude level A1 and A0. In another figure you can see this is the baseband data, this is the carrier signal, and you will get the modulated signal, that is ASK. I will show you the another example of ASK. Modulation of digital data ASK. Strength of the carrier is varied to represent binary 1 0. Both frequency and phase remain constant while the amplitude changes. Commonly one of the amplitude is 0. Now here you can see B is binary, that is symbol 0 or symbol 1 will be transmitted, right. Now you can see we will represent 1 as a plus a voltage and 0 as 0, 1 as a plus 1 voltage and 0 as a 0. Our data is 1 0 1 0 1 1. Now you can see this is the type of which type of modulation line coding technique is, that is we are using here unipolar. The unipolar, and it is RZ or NRZ. You can see for the whole TB duration we are representing it, so it is NRZ, unipolar NRZ. This 10111 data is represented by the unipolar NRZ type. Now we are mixing this signal with the carrier signal. The carrier A cos omega ct, or you can write A cos 2 pi fct. Now this amplitude, the amplitude of the carrier is varied with respect to modulating signal. Now frequency and phase remain constant, only the amplitude changes. Now how it will change? When you are mixing these two signal, at one bit the same carrier will be produced. Here you can see the same carrier is there when 1 is there. For 0 there is no carrier, for 0 there is no carrier. Again whenever the 1 came, we have to show the carrier, carrier is there, right. When 1 is there, it's on, and when 0 is there, it's off. It's also known as on and off key. It's known as on and off key, right. In this figure you can see here our data is 1 0 1 1 0. This is the carrier signal. When we are mixing these two signal, we are getting this carrier and 0 again carrier, at last is showing the 0. This is the block diagram. Here we are inputting the unipolar NRZ pulse, oscillator carrier signal, and then we are getting the ASK waveform. The equation of this ASK waveform will be A cos 2 pi fct or 0. It's for the 1 bit and it's for the 0 bit. This is the frequency spectrum of ASK. This is the carrier frequency. This is the modulating frequency VDF, and we will replace over here carrier. Then it will become band pass modulation. Now demodulation, only the presence or absence of sinusoidal in a given time interval needs to be determined. Advantages of ASK: simplicity. ASK is very susceptible to noise interference. This is a disadvantage. ASK used to transmit digital data over optical fiber. Now this is the analytical expression for ASK. This is the equation A cos omega ct. When the binary 1 is transmitted, for the binary 0 is transmitted, it will be showing the 0. Now you can see here we are replacing A by root 2p because carrier power is A square by 2. Now what will be the value of A? That is root 2p. So here we are replacing A by root 2p. cos omega naught t. Now we can replace P also in terms of energy. How? Energy is power into time. Now what will the value of P? EV by T. Here we are replacing P by E by T. So the expression is 2E by T cos omega Ct for binary one, otherwise will be showing 0. Excuse me. Now the bandwidth of ASK, when the pulse 1 is transmitted, it's having a amplitude A for TB duration. If we take the Fourier transform of this, it will show like this, 1 by TB minus 1 by TB is the Fourier transform of this term. The Fourier transform of carrier signal, carrier is there, the Fourier transform of carrier, that is FC minus FC. Just a minute. FC minus FC, right? Now we are mixing these two signal, generating a carrier signal. The carrier will be replaced. This modulating signal will be comes over carrier signal, that is FC plus 1 by TB and FC minus 1 by TB. Now we have to find out the bandwidth. So you can see this range, maximum range and the minimum range. So FC plus का 1 by TB minus FC 1 by TB. So it will give you 2 by TB, the bandwidth of ASK. We can write 2 FP or we can write 2 RB, because RB is equivalent to 1 by TB is equivalent to RB. 1 bit per second we are transmitting. Now here you can see this is the bandwidth spectrum of ASK, that is 2 by TB. We can take as a 2 FP also, right? So that's it for the today's session. In next session we will continue with the demodulation of ASK. Thank you.